Hello all, welcome to part 33 of the Wireless LAN Security Mega Primer. So in this video, we will finally go ahead and crack PEEP. So understanding the insecurity in PEEP. So if you remember, in the last video we had seen that PEEP primarily works by using server-side certificates. So the server provides the client with a certificate which the client ideally needs to verify and ensure that this is the radius server it needs to connect to. And then if all goes well, then the connection happens, credentials are sent, authentication may fail or succeed depending upon which the client would get access to the network. So the insecurity basically is that it is very easy to create a rogue radius server with fake certificates. And in many cases, like in many handheld devices, the wireless client software may not even prompt the user saying that there is a problem here, the certificate is fake, or many a times because of the user not being aware, he may even accept fake certificates. So how can this be used to crack PEEP? Now here is a very simple sample scenario. The attacker sets up a honeypot which is going to advertise a WPA enterprise network which is going to use PEEP, and he can very easily do this by using the free radius WPE, which is a modification to the free radius code. And using this, what will happen is when the client would connect to this network, the server would go ahead and present the client with its fake certificate. Now, if the client accepts that certificate, then a TLS connection, TLS tunnel would be created between the wireless client and the radius server, through which MSCHAP v2 based credentials would be sent through. Now, what the fake rogue radius server will do is that it will just go ahead and cache these credentials in its log file. And then after that, we will go ahead and actually use a dictionary attack to break the challenge response pair of the credentials sent by the client to recover the original password. And to do this, we will use a popular tool called ASLeap, created once again by Josh Wright. So what is the network architecture? So we have a honeypot, which what we've done is we are using a legitimate access point. Unfortunately, Airbase NG does not provide a way directly by which you can actually go ahead and mention a radius server. A workaround is to use the host AP drivers. I may create a video on how you can probably do it with that later on. But for this setup, all we are doing is we are bringing up our honeypot access point, which is our real access point, and that is connected to our backtrack VM over an Ethernet connection. And on this interface, we have free radius WPE running, and we also have a wireless interface through which we are monitoring the traffic going over the air between the client and the access point. So let's go ahead and begin our attack demonstration. So this is our backtrack instance, and what we are going to do is very quickly, the radius server is up and running based on what we've done previously, and we are monitoring the free radius server WP log file located here. And now let's go ahead and launch Wireshark first to monitor the wired side of the interface, which is going ahead and peering into the connection between the radius server and the access point. Right, and this, at least in my setup case, is ETH1. Let me just go ahead and quickly add that what we are interested in is just the ETH packets. Now let's also bring up our wireless interface by connecting our Wi-Fi card. So loading up Wireshark is really not required, but I mean, I'm just doing it so that we can go ahead and enjoy the success of the hack a little bit more. So let's wait for the wireless card to be recognized. I guess I'll probably have to assign it to my guest, which is the backtrack VM. Should probably see it appear here in just a second. And we'll once again create a monitor mode interface. So while this is loading, hope you're enjoying the series. I think probably 3 or 4 more videos and the series would be over. And after that, I'm just going to go ahead and incrementally add new videos whenever required. Right, so we'll go ahead and set the channel to where the AP is, which I know already is on channel 1. If you don't know which channel your access point is, you could go ahead and use arrow dump first to monitor the air. And what I'm going to do is start sniffing on Mon 0. You're going to see tons of traffic right now. But what I'm again interested in is just the EAP packets, right? So let's go back to our setup, and now we are monitoring the log file. Now what I'm going to do is I'm going to connect to the honeypot. Now please note, this could also happen using a misassociation attack. We could force this with a deauthentication attack, or a roaming client may just inadvertently connect to our access point if there is an SSID along with similar security profiles as advertised by us in its preferred network list. So multiple ways. Here I'm just voluntarily connecting to it. So I connect to SecurityTube. And the moment I do that, if you notice, there is an error which actually says, well, verify certificate. Let's click on show certificate, and this says it is not by a trusted authority. Now, here is a little problem. I mean, probably we as a security conscious, aware user are able to figure out definitely, this is bogus. Example certifying authority and whatnot, right? Locality somewhere, organization example.inc. But what may happen is a user who is unaware of all of this may just go ahead and think that he needs to accept this certificate. I think it's probably just vanished. Let me reconnect to the network once again. And he may just go ahead and accept the certificate. Now this would cause a lot of issues. We'll see how in just a second. Let me reconnect to the network. And let's say we hit on continue. The moment we do that, well, it asks us to go ahead and add this certificate to the chain of trust. Now, if we do this, this is going to be a major problem. And I'll tell you why. Because the moment we do this, this certificate has actually been added to our keychain. And from now on, this certificate will be blindly trusted by the client, which is our wireless interface. And if you notice, automatically based on some credentials which I had put in a while back, it's even finished the authentication. Now these are not the correct credentials, so let me probably go ahead and create a profile for this network, which is typically how you would go ahead and do this. And we go to advanced .1x, take up PEEP demo. This is the one where we are. And what we could even do here is, by selecting this, you could have an outer identity, which you could go ahead and select. In the last demonstration, what had happened was that I think one of the previous profiles were used. That's why you did not see pond. But if you just have that profile, you would go ahead and see that. So now let's go ahead and connect with this. It asks us for our username and password, and actually tries to authenticate on its own using a username and a password, right? Once again, these two are something which the system is automatically going ahead and using. So let's suppose that we do not have something created, which is we voluntarily go ahead and remove both of these, right? this is what is actually happening, is that it is ending up using this profile instead of the other one. Let's click OK, apply, and now let's bring up our interface again and have the user manually enter all the credentials, right? So if you notice now, once again it is trying to authenticate to the network, and we should actually see ideally that it should go ahead and ask us for various credentials. What we could do is, now there are various ways you can go about this. Just quickly disconnect and maybe add a profile which we would want to create for the network. So let's say we add a new user profile saying SecurityTube. We'll say prompt, and the only mechanism we want allowed for the time being is just peep, right? And when we select this, we could also go ahead and select the SSID. Let's just check if everything else is done. Okay, let me, and now let's click on connect. It asks us for a username and password, just so that the username password is something which will eventually crack. We'll enter what is there in our dictionary, right? And if you notice, basically we are able to see something using the username and password which we just entered, right? So this is the username, this is the challenge, this is the response. Now on Wireshark we would actually have a decent amount of traffic, because we've had multiple sessions, but what we really want to look at is basically just the last session. And could even just restart the whole process. Just takes a second to do that. Right, we could do the same on ETH1. Go back to our little wireless client. Turn airport off for a second. Turn it back on. And enter the username and password, right? Let's go back here to our VM. And right now we have a very clean trace of the entire exchange, right? And finally the EAP success which is coming in. So now how do we go about cracking what we've just found, right? So for this, what we will use is a utility called ASLeap. Let's open up a new terminal to make this faster. And I'll go to a special directory where I already have a dictionary. This is the default dictionary in Backtrack. The only change being that I have actually added demo 1, 2, 3, 4, 5 at the absolute end, which is not there in the dictionary by default. Now we'll use a utility called ASLeap, and the inputs to this is going to be the challenge and the response along with the dictionary. So let's say we give the challenge as input. I think it was -c. Let's copy the challenge, and we'll also copy the response for the challenge, which is this part, pasted as well, and then we feed it the dictionary file which is currently there in the same directory. Now if the dictionary file actually contains the password, then the cracking process will succeed and we will see the output, right? Now as you can imagine, every time of course the challenge and the response would change. So if we take up the previous one, this would just amount to something else entirely. But the cracking process should ideally give us the exact same password, right? Perfect. And if, let's say, our challenge and our the passphrase is not there in our dictionary, then we should not be able to crack it. So this is just something arbitrary. I don't even know if it's there in our dictionary or not, but I'm guessing it's not there. Let's just see. This has a username demo and then a different set of challenge and a different response. Let's see what happens here. And okay, the password was demo, right? Interesting. I think I must have just done it when I was testing the whole setup, and looks like I chose something which was pretty bad. So this is exactly how, if the user, right, if a gullible user goes ahead and accepts the certificate, which also gets added onto his trusted chain of certificates, then it would be very, very simple for an attacker to break his PEEP credentials, which he has sent to the fictitious Radius server, right? So that's all for this video. In the next video, we will actually take up Windows as a case study for PEEP, look at various configurations and even third-party utilities, and see how we could go ahead and compromise PEEP in a Windows environment. But the point remains that regardless of whether you're using Windows or OS X or anything else, or even your mobile phone for that matter, if you accept a fake certificate, nothing can save you. This is similar to the SSL man-in-the-middle attacks, where if you present a fake certificate to the user and he accepts it, well, game over, right? That's all for this video. Please leave your comments behind. I really look forward to reading them. And at the very same time, if you could make a donation, this is an absolute free effort. We've put up tons of videos and we plan to put up even more videos over time. So if you could donate, we'd be very thankful and grateful. Thank you very much. Have a great day ahead. Bye-bye.